quantity is a measurable property or feature of an object. A physical quantity is a measurable feature of an object. It's just a measurable feature. Measurable feature. Okay. That is what we mean when we say a physical quantity. Something that is that can be measured. So the measurable feature of anything. Okay. So for example, let's get a house. Okay. So if you want to build this house, you have to know the dimensions. Okay. You have to know the length, you have to know the length, breadth, and also all the dimension. So those features that you can measure there, they are what we call physical quantity. Those properties that we can measure. The measurable features of an object are called physical quantity. Okay, that is what we mean by a physical quantity. So this physical quantity can be anything. Okay, it can be categorized into two things. A physical quantity can be categorized into two things. What do we mean by that? Under a physical quantity, we have what we call a fundamental quantity. I remember teaching this. A fundamental quantity and a derived quantity. Okay, a derived and a fundamental quantity. Okay, that is, those are the two physical quantities that we have. We have a derived, we also have a, a fundamental. So what do we mean when we say a fundamental? When I say something is a fundamental, for example, we define an atom as a fundamental, or we define a cell as a fundamental. It's a fundamental something. So a fundamental is a base, a basic. Okay, you can't do without that. So if we're talking about physical quantities and you want to define a fundamental quantity, it's a quantity that cannot be derived from any other quantities. Okay, it cannot be derived from any other quantities, or it just exists on its own. That is what we mean by a fundamental quantity. This fundamental quantity, you can also call it a base, okay, or a basic unit. It exists on its own. You don't have to get anything like you get a length, you multiply it with time, you get something. No, the fundamental quantity, it just exists just the way it is. Okay, so examples of physical quantities, we have length. Okay, length is measured in meters. Okay, length is measured in meters. So length is just a fundamental quantity because you can't get length from anything. Okay, it's just length the way it is. There's no unit where you can multiply like seconds times time, you get a meter. There's nothing like that because length is a fundamental quantity, meaning it just exists the way it is. Okay, another example of a fundamental quantity, we can say time. Okay, time is measured in seconds. Okay, even time itself, it's a fundamental quantity because it just exists on its own. You can't derive it from something. It's a fundamental thing. Okay, another example of a fundamental quantity, we can say uh, luminous intensity. Okay, or luminous intensity. You can add more and more there. Okay, then when you talk of a derived quantity, okay, a derived quantity can just be defined as a quantity that is made or by multiplying or dividing two fundamental quantities. Okay, a derived quantity is a quantity that can be formed by dividing or multiplying two fundamental quantities. What do I mean? Okay, for example, let's get length and time. Okay, if I say length divided by time. Okay, for example. let me use the unit for length. The unit for length is meter. The unit for time is second. We form something that is called the meter per second. So this meter per second is not a unit, okay? It's not a fundamental unit. I've gotten it by getting two fundamental quantities. So if I have something like this, and I know that that is velocity. Velocity is measured in meters per second. So we can say a derived quantity, an example is velocity, because velocity is formed by two fundamental quantities, that is length and time, and it is measured in meters per second. Another example of a fundamental quantity, we can say force. Okay, why? Because a force has a formula, and I know that force is equal to mass times acceleration, which gives me a mass is measured in kg, acceleration is meters per second squared. And if you're given something like this, we know that this is a Newton. Okay, so hello, so uh, guys, let's mute our mics.
This, Bajo.
Let's mute our mics. We're making a lot of noise. Okay, thank you. So a force, yeah, a force is measured in Newton, but a Newton is not a fundamental unity. Okay, it's gotten when you multiply mass and acceleration. So a force is another example of a derived quantity, force measured in newtons. Another example there, we can talk of pressure. There are a lot of things, okay? Can talk about pressure. Pressure is given by force over area, and force is measured in Newton. Area is measured in meter squared. Okay, so Newton per meter squared, or Pascal. Okay, pressure. You can talk of a lot of things like on derived quantities. Okay, there's no restriction. We have a lot. You can just see whatever you can derive. Derive is called a derived quantity. So let me just add a last one. We can talk of acceleration. Okay, because acceleration is given by final velocity minus initial velocity divided by time taken. Okay, so we see that we have velocity and time. Okay, though velocity is also a derived quantity. Okay, so velocity, which is meters per second, and time is second. So meaning that acceleration is meters per second squared. So we have acceleration here. It's also a derived quantity, acceleration. Those are examples of derived and fundamental quantities. Any questions, guys, from there? Any questions? Any questions? If you have a question, you can ask. Feel free, guys. We are interacting, okay? Feel free to answer and participate. Okay, quietness means that everyone is just okay with whatever they've been given, isn't it? Okay, let's proceed. Let's proceed. Let's proceed. Okay, the next thing we're going to talk about is significant figures. We're going to talk about a significant figure. Significant figure. Okay, significant figure. I'm sure you've heard of how many significant figures are there. We all have heard of that, isn't it? We've all heard about a significant figure. So today, let's define a significant figure. What is a significant figure? Okay. So assume that, let's say, uh, we have Lulu. Okay, Lulu's iPhone measures something of a length of about 6.8 centimeters. Okay, we were trying to define a significant figure. Let's say Lulu's iPhone measures 6.8 centimeter. Okay, isn't it? So if you look at Gibson,
Outside.
you can just mute your mic off. Hello, okay, Gibson, you can mute off your mic.
Sorry?
Hello, you can mute off your mic.
Side,
Yeah,
side.
thank you. Okay, so I was trying to define a significant figure. Okay, let's say we have a number 6.8. Okay, let's say we have a number 6.8. We know that the digit 6 is certain, isn't it? It's certain. If I say 6, it's a certain number. Okay, so then the 8 there is uncertain. Okay, uncertain number. Let's say we have 6.8. We can say 6 is certain and 8 is uncertain. Okay. Okay. Why is it uncertain? Because it can either be more or less than 0.8. That is what we mean. Okay. So those two digits are known with certainty. Okay. So the first digit and the second digit are called the significant figures. Okay. So if you look at 6.8, it means that it has two significant figures. Significant figures. Okay. So for example, let's say I give you 1.8. Okay. 1.8, and I ask you a question. How many significant figures are here? Neither. What do you think? How many significant are in that number? Neither. What do you think? Hello? Okay. Oh, guys, keep quiet. So, silence means it's either a person knows or doesn't know. Okay. So, this number has two significant figures. How did I know that that number has two significant figures? Okay. That is what we are looking or talking about today. Okay. So, let's talk of how you, for example, we have zero digits. Okay. We have zeros. How do you deal with zeros if you are trying to know the number of significant figures? How do you deal with zeros? Okay, for example, if I write 5.0, if I write 0.2, if I write 20.01, okay, we've seen these scenarios. I've given you 5.0, 0.2, 20.01. Okay. Then I say, how many significant figures are those? Okay. So before we answer these questions, let's understand about some rules that we used when we are classifying the number of significant figures. So we're going to begin with the first point. Those who are writing these notes are very important. Okay. They're going to help you in the entire course of physics and also chemistry. So let's talk about non-zero digits. Okay, non-zero digits. So we can have non-zero digits. So non-zero digits are always significant. Always significant. Non-zero digits are always significant. What do I mean? A non-zero digit is a number that is not a zero. Okay. A non-zero digit is a number that is not a zero. So any number, as long as it's not a zero, it's always significant. Okay, example 38.47. So we know that all these numbers are non-zero digits. Don't be confused by a point. A point is not a number. Okay. So this number has how many significant figures? It has four significant figures because all those numbers are non-zero digits, and non-zero digit numbers are always significant. So due to time, we're just going to give one example. And number two, so if you're dealing with zeros, okay, so zeros are sometimes significant and at times they are non-significant, okay, are sometimes significant, sometimes significant, significant, and at times they are not significant, and at times they are not significant. Okay, this statement sounds so I can say ambiguous. If I say zero, sometimes it's significant, sometimes it is non-significant. What do I mean? So we can put some rules here. When do zeros become significant and when do zeros become non-significant? So let's look at the first case, okay? So if a zero is at the beginning of a number, it's always not significant, okay? If a zero is always at the beginning of a number, zero at the beginning of a number at the beginning is non-significant, okay? What do I mean if I say a zero before a number? A zero at the beginning of a number is non-significant. I hope you can see my handwriting. If you can't see, you can just tell me to adjust my handwriting. Okay. So what do you mean? So a zero at the beginning of a number will never be significant. Will never be significant. Okay. Never be significant. Take note of this. Never be significant. I'll just use SIG to represent significant. So for example, 007, 007. How many significant figures are in this number? So we've seen a zero is at the beginning of a number, isn't it? So there's only one significant figure in that number. Another example is 0.02. So you can see that a zero is at the beginning of this number. So even in this number, the non-zero digit is always significant. So you can say that non-zero digit makes a one significant figure. Okay. Look at another scenario where a zero can become significant. Okay, so we can have a number like 2001. Okay, we can have a number 2001. So are those zeros significant or non-significant? So this is the rule. So zeros between two. Hello guys, let's mute our mics. Let's mute our mics. Hello. Zeros between non-zero digits. Non-zero digits are significant. Non-zero digits are always significant. Are always significant. Okay.
Please, before you proceed, I'd like to ask.
Oh, you're welcome, please. You can ask.
Yes. So I didn't understand that. Yes, I'm asking. I didn't understand much here from what we're coming from. Where is 0.02? You've written one significant figure. I didn't understand. The meeting is actually cutting off frequently, so I'm making involved.
Oh, all right. All right.
I did-
Oh, it's cutting. Okay.
Yes.
Let me just explain why I've said there's only one significant figure. Okay. So there's a rule I've written here. Number one, we said all non-zero digits are always significant. Those who are making noise, please let's keep quiet. We give way to those who are listening, guys. Okay, non-zero digits are always significant. Okay, a non-zero digit is a number that is not a zero. So whenever you see a number that is not a zero, it's always significant. Okay, any number, if I just say 4, this number is a number. Okay, so
device is connected successfully.
hello,
The
hello,
Bluetooth
we are making noise, guys.
device connected successfully.
Okay, so 0, if I write a 4 is a number. Okay, so if I'm talking about significant figures, in short, we want to find how many numbers in that number add a value, okay, to that number. Oh, that is a significant figure. So if I write 4, 4, 4, how many numbers in this number are significant? So we go back to the rule. Okay, non-zero
The
digits are always
Bluetooth device,
significant figure,
the
are always
Bluetooth
significant.
device
So I
is
have 4,
connected
4,
successfully.
4. So I have 3 significant figures because I have 3 numbers in this number. Any number, even your mobile number, 0976, and so on and so forth. How many significant figure? So there are 3 significant figures. Okay. So, but when we look at the second point, it says zeros are sometimes significant and at times they are non-significant. So I've written a case there. There are A and B. So in case A, we said 0 at the beginning of a number will never be significant. Are we together, Kapamwe? Okay. Zeros at the beginning of a number will never be significant. But take note of the first point, which is a non-zero digit number are always significant. Okay. But here, when we say a 0 at the beginning of a number will never be significant. So that's why I wrote a number 007. So 007, we have 2 zeros at the beginning of this number, and we said the zeros at the beginning are not significant. So we discard these as non-significant figures, but we have a 7 here. So this 7 is a non-zero digit, and the non-zero digits are always significant. Even though I have 3 digits in this number, but these 2 zeros at the beginning are not significant, making 7 to be the only significant figure there. So it's only one significant, just the same as 0.02. 0.02, I have zeros at the beginning of this number. Okay, we said that zeros at the beginning will never be significant. But when we go to rule number 1, 2 is significant because it is a non-zero digit and it is the only significant number in that number. So we also have one significant figure. I hope I'm clear, Kapambwe. Any question from there? Hello?
No
Okay.
question means it's Priscilla, not Kapan.
Oh, I'm seeing on the meeting there. All right, Priscilla. All right. Let's go to this point. Non-zero digits. Zeros between non-zero digit number. A non-zero digit number is any number that is not a zero. Okay. If I write 2, I write 5. These numbers, they are significant, isn't it? They are non-zero digit numbers. So if I put zeros in between these non-zero digit numbers, okay, it means that all these zeros are significant because they are between non-zero digit numbers. Okay, so it means that this number has how many significant? 1, 2, 3, 4, 5. So this number has 5 significant figures. That is what we mean when we say zeros at some times they act significant and at times they act as non-significant figures. Okay, so let's look at this number 0, 2, 0, 2, 0. How many significant figures are in this number? How many significant figures are in that number? Who wants to try? Who wants to try?
3.
3. Thank you very much. Chilawa, Mwanza. Thank you. Oh, mate, you want to try also? You can say something. Mate Inambao. Okay. Indeed, in this number, we have three significant figures. Three significant figures. How did I get that significant figure? So in Rusi, a zero at the end of a number is non-significant, and a zero at the beginning of a number is non-significant. Let's look at these numbers now. So this number is significant, and that too is significant, and there's a zero in between those two significant figures. Okay, so making this zero to be significant also. That's why we've said there are three significant figures there. I hope I'm clear. So C, let's look at C. So rule C says that zeros at the end of a number that contains a decimal point are always significant. Okay, a zero at the end, the zero at the end of a number contains of a number that contains a decimal point. A decimal point are always significant. Are always significant. SIG to represent significant. Okay, that is another point that you need to take there. Zeros at the end of a number. For example, if I write 47.0, okay, 47.0. How many significant figures are in this number? Remember, we said zeros at the end of a number that contains a decimal point are always significant. So it means that this zero is also significant because there's a decimal point and this number is significant. So if this number is significant and then there's a decimal point here, this number also, this zero becomes significant. Okay, there's a difference if I write 470 and 47.0. Okay, this zero becomes significant because this number is significant. And if I add the point, it makes this zero to be significant. But if I write this 470, a zero at the end of a number is not significant. So here we have 2, here we have 3. So because of the third rule, which says that zeros at the end of a number that contains a decimal point are always significant. Okay, I hope I've made myself clear. Let's look at the last rule, the D one. Okay, the last rule, it says that zeros at the end of a number. Okay, zeros at the end of a number does not contain that at the end of a number that does not contain a decimal. That does not contain a decimal point. Okay, may or may not be significant. May not be significant. Okay, so I've written a sentence, and then that sentence at the beginning it makes sense. Then at the middle here, it sounds as if it doesn't make sense, but let's make sense out of the same statement. We said that a zero at the end of a number that does not contain a decimal point, okay, may or may not be significant. So it means that sometimes it can be significant or sometimes it may not be significant. Okay, for example, let's say I have a number written as 2.43 times 10 kilometers. Okay, And I also have a number 2.430 times 104. Then I also write another number 4300 times 104. Then I ask you a question, how many significant figures? Okay. How many significant figures does this number contain? So this number, the first one, has how many significant figures?
3.
Hello?
Oh, base times 10.
It has how many significant figures?
It has
Okay.
3.
So the first one, it has 3. Thank you very much, Priscilla. Then the second one has 2430, isn't it? Again, this one has 5. This one has uh how many significant figures? This one has 4, isn't it? But this number is just the same as 24300, isn't it? The same number, we can say, okay, this number, if I write it in scientific form, okay, if I get 24300, and then I said write in scientific notation, we say it's 2.4300 times 10 to the power how many? 4, isn't it? Kilometers. Sorry, this is to the power 4. Okay, don't get confused. This is to the power 4. This number is just the same as that number. Again, it's just the same as I write this number. Nothing will change. The same as times 10 to the power 4. The same as if I write it 2.43 times 10 to the power 4. All these numbers are the same. If you multiply, you're going to get the same number. But the number of significant figures, they change. Okay, they are changing depending on the form that you have written it. Because if you have written this in the form of this, it's also correct, but the number of significant figures is different. If you write it like this, it's the same as this number, but the number of significant figures. That's why I said it may or may not be significant. Okay, we have talked about fundamental units. We have talked about significant figures. Let's talk about standard form. What do you understand by standard form? What do you understand by standard form? So a standard form is a number written in form of a times b to the power x. That's a standard form. A number written in the form of a times b to the power 4 to the power x. That is what we mean by a standard form. So this standard form is also known as scientific notation. The scientific notation. Okay, scientific notation. Notation. So it's a standard form, or it's just a method or an expression of work which is very large into a small number. Okay, the expression of a very large number into a small number. That is what we mean by standardizing it or writing it in its scientific notation. For example, if I ask you a question, uh, what is the what is the mass of the Earth? The mass of the Earth is somewhere is 5 9. Hey guys, let's make noise. We're making a lot of noise, guys. The mass of the Earth is 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 4 5 6. So again 1 2 3 1 2 3. So this is the mass of the Earth. Okay. So if I tell you to write the mass of the Earth, are you going to manage every time in the book we write this number? Always you write this number. It will be tiresome, isn't it? So this number, let's write it in a smaller number. Okay, so this number, we can write it as 5.97 times 10 to the power 27. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 26, 27. It's a two zeros there, like that. So this is what we mean by writing it in standard form. Okay, so these two zeros, they can go out. Okay, yeah. So we've written it in the form of a times b to the power x. So now, how do you write a number in standard form? How do you write a number in standard form? So we have numbers written like the way it is. For example, 7, 6, 5, 4, 3, 2. Okay, I want to write this number in standard form and correct it to specified number of significant figures. So you assume, uh, guys, let's maintain silence in the group. Take note what your mic is on. You can just mute off your mic. And Muchanga, your mic is also on. You can just okay.
Mic is on.
Yes. Thank you. Thank you so much, guys, for that. So if we write a number like the way it is, okay, any number, the decimal point is at the far end of that number, any number that I write. So we get this point and move it, see, so that it goes between the first number and the second number. Okay, so it moves a certain parameters. So from this point, it goes to that point. It also goes to that point. It also goes to that point. It also goes to that point, and it also goes to that point. So this point has moved a number of times. So 1, 2, 3, 4, 5 times. So I have 7.6543 times 10 to the power 5. This is how we write it in standard form. Then you correct to a given number of decimal places. For example, if I say and leave it to two decimal places, okay, so it would be 6.5 times 10 to the power 5 to two decimal places. This is how you write it in standard form. Okay, so today we'll end here.